Alrighty, welcome back. This is day 4, okay, where we're going to talk about horizontal shifts to our graph as well as all the other transformations. But here, horizontal shifts, whenever we do these with sinusoidal functions, we call them phase shifts. I don't know who decided to change the name, but they did. So we're going to graph that. So we're going to get to our last type of transformation. So yesterday we talked about B, right? So I'm going back to my parent function graph. So we've talked about A, which is the amplitude, right, where we stretch it. D is going to be our change to our midline, right? That's going to be a vertical shift, okay? And then we talked about B, which either stretches or shrinks our graph, and that changes our period, right? So that's where we do 2 pi over B, all right? Now, our last shift is going to be a horizontal shift left or right. Remember, whenever we're shifting to the x or the theta, it's always the opposite direction, just like you would normally expect. So it can be a positive or a negative. So we're going to do that today along with some other types of transformation. So if you take a look here, we're going to graph 2 cosine and then in parentheses theta minus pi over 2 plus 1. So the first thing you want to do is always think about your midline. So here we have a midline of y equals 1, okay? So I see from your homework, some of you are not drawing the boundaries, which is fine. You don't have to, okay? But I do think it helps because your sine and cosine function should never go outside of your boundary lines, okay? So they are helpful, but again, you don't need to have them. I do, if you're not going to use your boundary lines, I highly suggest, or I pretty much require that you make sure you're labeling your axes so I can see where your mins and maxes are, all right? So that's our midline. Then our amplitude is the second thing you want to take a look at. Our amplitude here is 2. So that means our maximum is going to reach, is 2 above our midline. So that's a maximum of 3. And then our minimum, we would go down 2. So that would happen at -1. So then we have our lower boundary line here at y equals -1. Our upper boundary line at y equals 3, okay? And then those are the two things we've talked about. Now, if you take a look, there's no change to my period here, right? So amplitude is 2, period is 2 pi, okay? So you're gonna be asked for that on your homework, all right? Then the other thing you're gonna be asked for is, and I'm gonna add this in here, your phase shift, okay? So what that is, so again, our period didn't change because there's no coefficient to the theta. There's no B value. So our phase shift is just our left or right. So if you remember, if we have minus pi over 2, right, then that means that's actually a shift to the right, not the negative, but the right. Another way to think about that is usually theta, right, we start at 0, don't we? But now we have this. So if you set this equal to 0, then your phase shift is actually pi over 2, a positive pi over 2. So when we go to graph this, we're going to start at not 0, but we're going to start at pi over 2. Now, where are we going to end? So we're going to stop after a full period, right? Now, I know the textbook asks you to graph 2. You really only have to graph 1. A lot of you on your homework are graphing 2, which is great. But you don't have to, all right? If you take a look here, our period is 2 pi. So what I'm going to do to get to my stopping point here is I'm going to add 2 pi, okay? Because I'm going to start here at pi over 2, and then I'm going to graph across, right? And stop 2 pi after pi over 2. Now, if you want to add 2 pi, you really kind of need to think of that as, if I multiply this guy by 2 over 2, that's really 4 pi over 2, isn't it? And I'm just doing that so that I have the common denominator here. So if I'm adding 4 pi over 2 plus 1 pi over 2, that means I'm going to stop at 5 pi over 2, okay? Now, for graphing purposes, my graphing interval, which we talked about yesterday, right? We always take our period oops, misspelled that. Not a shocker, I know, but our period, right, and divide it by 4, okay, our new period. So here, our period, we haven't changed it, so it's just 2 pi over 4, which is pi over 2. So each time I'm going to add a pi over 2, okay? Now, what that means is here, if I have 1 pi over 2, I'm going to add another 1 pi over 2 for a total of 2 pi over 2, which means this reduces to pi. Now, you don't have to show me this, but this is what you should be thinking. Then I'm going to add another pi over 2. So this is 3 pi over 2, which doesn't reduce, so I just write 3 pi over 2. Then I'm going to add another pi over 2, right, which is 4 pi over 2. I'm just increasing my numerator, and this becomes 4 over 2, right, 2 pi. And then last but not least, right, I get to 5 pi over 2, which does not reduce, which is when I'm going to stop for a full period, right, of 2 pi. So that means I have all my critical points labeled on the x-axis. All right, so again, I'm just increasing by my interval of pi over 2, starting at my phase shift of pi over 2, because that's my phase shift, okay? And then I'm going to graph my points based on the shape. I'm going to graph based on my shape. So this is cosine. So if it's cosine, I have to start high, right, at my maximum of 3. Then I'm going to hit my midline at my second critical point, then my minimum, then again at my midline, and then I'm going to hit my max. Now, some of you are venturing and going up over here. So this should be in between. So do you see how when I hit my maximum here, I immediately turn down, right? Because that should be your maximum. So never venture above or below your boundary lines, okay? And that is our graph, okay? Our domain, again, is -infinity to infinity. And then our range, we're going to use our boundary lines, should be -1 inclusive to 3, okay? Now, on your homework, they're going to ask you for amplitude, they're going to ask you for the period, and they're going to ask you for the phase shift, okay? So those are the 3 things that we're going to be focusing on, all right? Now, this one I'm going to change the equation ever so slightly, so do this for me. It's going to be y equals sine, and then we're going to have 2 theta inside the parentheses plus pi minus 2, okay? Because you're going to have some homework problems that look like this, so I want to make sure we get to one like this. Now, here's the deal. If I go back to my standard form for these sinusoidal functions, you can see that the b is always factored out of this, okay? So it should never be inside of the parentheses. So whatever the coefficient is to the x or the theta should be factored out. So when I go to graph this, because, and I should say, the reason you want that is because then you can see your b value, which won't change, but your phase shift is going to change, okay, the value of that. You always want that c value to be isolated, right, and the b to be removed outside. So let me show you what that looks like, all right? So if you take a look at this guy, right, you see how this 2, the b value, and the coefficient to theta is inside the parentheses. You're going to want to go ahead and factor that out. Almost think about it as if you're dividing by 2 to both of these. So this is equivalent to sine 2 parentheses theta plus pi over 2 minus 2, okay? Now you can see this is your b value, right? That's your phase shift. Okay, and they should be separated into the factored form, all right? And then we also have a change to our midline. So the first thing you're always going to do is identify your midline. So that's the first thing. So y equals -2. So I'm going to graph that. is my midline. Then if you look, the coefficient to my sine, okay, is just 1. So that means my amplitude is just 1, okay? So that's the second thing you should do. So I'm just gonna, whoops, go up to -1, right? That's my upper boundary. And then my lower boundary is just at -3, okay? So that's the second thing you should do. Then the third thing you should do is always what we talked about on the previous day, right? Yesterday was find the period, right? So our period here, okay, is going to be 2 pi divided by the b value, which is always the coefficient to theta, even though we factored it out. So b is 2. So I'm going to divide by 2. So therefore my period is pi, all right? So there's my period. Here's my amplitude. Then the last thing I'm going to do here is step 4. I'm going to do that down below here. Can you guys, yep, you can see. Step 4. I know that this is a plus, right? Pi over 2. So really, if I set that equal to 0, because that's usually where I start, right? My sine function, but I'm shifting it. This, if I solve for theta, will be -pi over 2. So this is your phase shift. Okay, and that's the other thing your homework is going to ask you. So your phase shift is -pi over 2. That is your new start. Okay, so you're going to start at -pi over 2. Now, what you have to do to figure out the stopping point or the ending point is add your period. Well, if you look back up here, we're going to add a period of pi, which again, you're going to want to have the same denominator. So that's really, if I multiply by 2 over 2, that's really, right, 2 pi over 2, isn't it? So there, if I add 2 pi over 2 to -1 pi over 2, so -1 plus 2, that gives me just a +1 pi over 2. Okay, so now I have pi over 2 is my stopping point, all right? Now, that's all the stuff your homework will ask you for. Now, remember what we did for a graphing interval. We always divide by 4 to the period. So the period, right, we're going to divide that into 4 different parts so we can get our 5 critical points. So my period again is pi. So I'm going to increase by pi over 4 each time, okay? So if I extend this axis a little bit here, right, I'm going to start at a -pi over 2. And then I'm going to add pi over 4 to that. So if I want to add pi over 4 each time, I need to be dealing with a denominator of 4, right, to make my life easier. So hopefully you would agree this is really -2 pi over 4, isn't it, if I multiply by 2 over 2? So then if I add a +1 pi over 4, that's going to get me a -pi over 4, right? So that doesn't have to be reduced, so I can just pull that right up there, okay? Again, you don't have to write these at the bottom. If it helps you, you can, but that's what I'm going to be thinking, okay? So then it's -pi over 4. Then we add another pi over 4. So -pi over 4 plus pi over 4 is just 0, okay? So then I'm at 0. So then I add another pi over 4. So that's just pi over 4. So this is pi over 4. Then I'm going to add another pi over 4. So that's really 2 pi over 4, right? Which reduces to pi over 2. Now I'm going to graph 2 cycles just so you can see what this kind of looks like. Again, you don't have to graph 2 cycles, but I'm going to keep adding pi over 4. So this is 3 pi over 4, which doesn't reduce. Right, so that I go 2, 3. Then I need 4 pi over 4, which is really just pi. Then I'm gonna go 5 pi over 4. Then 6 pi over 4. So in my head, I'm thinking, okay, well, that's actually reducible to 3 pi over 2, right? And then if you look, here's the end of my first curve, right? Because I said I needed to graph from negative pi over 2. So that's 1. So I start here, 1, 2, 3, 4, 5 points, right? Then 1, 2, 3, 4. And then I need my 5th point here. So this was 6 pi over 4, right? So then I got to add another 1 pi over 4. So this is 7 pi over 4, which I can't reduce, so I'll just bring it right up there. And that is my axes, okay? So each time, and this is tricky, okay? This is a full curve. You have to graph for me the beginning of the phase shift, the start, and then add your period to get your ending. So technically you could end there. But I extended it beyond that and kept adding my interval, my graphing interval of pi over 4 each time to get 2 cycles, all right? So now what does this look like? Well, we have, right, a positive amplitude. So if this is sine, I start at my midline, and then I just graph like I normally would, okay? I have all the boundaries and all the axes. So I'm gonna hit my maximum, then my midline for sine, my minimum, and then back here. So look, this is all you really need to graph for me. Can you see how that is one sine curve right now, right? So we increase, decrease, and then we come back to 0, all right? That would be enough, but I went ahead and graphed another cycle. So this went up, then we hit our midline, then we hit our lower point, and then we hit here. I guess, I'm sorry, I miscounted. We don't need that. Okay. So then this should go up, down, up, and then here. Oh, that's why, because I forgot to count that as one of my critical points. Now, this makes sense because can you see that this is 1 pi over 2 to 3 pi over 2s, right? So 1 to 3, that's a difference of 2 pi over 2, isn't it? Which is really pi. Is that a full sine curve? Yes, it is. Which is where the whole, right, our period is, which is what our period is, from one beginning point at our midline all the way through our cycle to the ending point. Okay, so back to our domain range, right? I don't think your homework asked for this, but domain is negative infinity to infinity, and you guys did a very nice job on your homework with that. Then our range, right, should be from -3 to -1. Then our amplitude, right, there's no change in our amplitude. We have that already. Our period over here is pi. And then the other thing they will ask you for is your phase shift, right, which is going to be negative pi over 2. Okay? So, going back to our parent functions here. Okay. This guy. This is the first thing you should always find. Okay, so that's what we kind of started with when we did these lessons. That's your midline. You're going to graph that first. Then you're going to figure out your boundary lines by finding your amplitude. Always be careful. If it's a negative, then it's going to be a reflection over the x-axis, okay? Then the third thing you should do is find your period, which is 2 pi over b, okay? Then your phase shift, okay, so this is the C value is your phase shift. For your phase shift, you're always going to do the opposite, right? It's always the opposite, okay? And then you're going to take your period, right? Your phase shift, whatever it starts with, okay? So whatever the C value is, and you're going to add your period to it. So let's say it was x minus pi over 4, let's say, okay? Since it's a negative, that means we're going to shift to the right, Okay, you could also set it equal to 0, okay? So therefore your phase shift is pi over 4. So then you would start at pi over 4, and then you would add your period. Let's say, for example, right, so this is our example. Our period, our B value was 4, right? So therefore, our new period, right, would be 2 pi over 4, which would be pi over 2, okay? So you would have pi over 4, that would be your beginning, your start, and then you would add pi over 2 to that to get your stopping point, okay? So pi over 4 plus pi over 2, which is really, in your head, you have to think of it as 2 pi over 4 if you multiply by 2 over 2. So therefore, our stopping point would be 3 pi over 4, okay? And then the last thing we did is our graphing interval, right, is this, right, that we talked about yesterday. To use your graphing interval, you're always going to set your axes based on your new period divided by 4, and always start at your new starting point with a phase shift and stop at your ending point. You only have to graph one curve for me, okay? We will be practicing this more because the phase shift, I think, can be the most confusing of all the types of transformations. So we will be talking about tomorrow more of this, and then I'm just going to add in writing equations, okay? And then next week, I know everybody's very excited, but we're going to start talking about word problems, which you will see are actually easier than these, okay, once you get the hang of these, all right? I hope you are all doing well, okay? And if you guys have a question, you can also write it on your homework because I'm looking at your homework, and then I may be able to answer that in my comments on Schoology, or if you send me an email, hopefully if it's a quick question, I can send you a video answering your question. So feel free to email me your questions as well, okay? Again, I hope you guys are doing well, and I will talk to you soon.